Yeah, well, I'm from robotics background. I started my research career in my undergrad research on bio-inspired robotics. So I worked on it a little bit, but I later more toward the soft material community while it's kind of still time to time work on robotics topics or robotics forks. But in general, it's very funny. The robotics and the materials community was completely separated when I first started my research like 10 years ago. But now, after a decade, like it's impossible to tell which is what. It's just immersed. Which traditional robotics people, like all the good IEEE fellows, those people that hate these changes. They're really not a big fan of it. But it's been changed. Like the notion of a robotic material have been immersed for a while. So it's very funny. Like, so that's why I kind of more like a material scientist engineer by doing things, but somehow I continue to communicate it and keep engaging with the robotics community just because a big portion of the robotics community has now been made out of the materials for mechanics forks, and people now talking about robotic materials, which is very interesting. It's impossible to imagine if somebody was in 10 years ago. It's just amazing development.
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Mara Dwini, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast. So maybe I would like to ask maybe first how you'd like to define yourself for you people listening. How would you like to define yourself?
Well, there are many personalities for researcher stakes, but I think I myself predominantly see as engineer. And I have my own definition about engineer. I think engineer is the folks who are solving the problem by using science. So I'm really about solving problems guy. So yeah, so I'm engineer, and I like to solve the problem, and happens to be it is based on science, good or bad.
Awesome. So you mentioned at the beginning that you started robotics and then in material science. Can you tell us again about what could be missing when you entered your PhD and you started working in designing the soft material for robotics application here? What was missing, or you still missing in the research here?
Yeah, well, it's a little interesting kind of process that how I switched to different fields. Like when I apply for grad school in my grad school application and SOP, and even when I got admitted by MIT and tried to find a lab to join, I wanted to go for robotics lab. So I applied, like I basically asked to join all the robotics lab, but somehow there was no funding to join. so so I like so therefore it's not like intended option, like intended choice. If any robotics lab in MIT mechanical engineering would get me at that moment, I probably do robotics still, like hardcore old school robotics. But at that moment, there was no robotics lab to join. I could join. So I had to go for plan B. The plan B is if I cannot work on robotics, I may work on materials or robots. Because I was excited about artificial muscle kind of thing for entire my bachelor period. So that's the thing. And one material then, because I was fascinated by software actuators and artificial muscle kind of thing for whole time, it was natural that, well, if it is a material, it should be soft material. because I didn't like the biology at the time, and I had so many horror story of my friends that I like feeding cells first and themselves about kind of those kind of like a bio horror story. So I didn't want to go too much toward the biology or biomaterial, but more like material by itself in a material science and engineering or mechanics aspect. But anyway, it was a soft material that is obvious plan B. So I went there, and somehow, as everybody doing the PhD in grad school, like research topics are just bumping in all the unpredictable directions. So what I currently do is complete mixture of lucks and serendipitous events, but somehow I was one of the robotic engineers, but I just couldn't do that for my PhD thesis because no lab, no robotics lab I could join, but somehow it's kind of going there.
Awesome. Maybe before going to that, I want to ask you in general, because I feel you're already a smart guy and I have, your opinion about the field, but I think you are more critical, and I would love to know your opinion when it comes to soft robotics field in general. What may be something do you think we still don't push so much here?
Well, I think every field have their life cycle as like a human being, as like kids, adolescent, young adult, and as aged or the good person. Soft robotics was very young field when I first saw it in my undergrad school, and it was actually to say the George Whiteside is known to be very much an innovator there, but it's not true in some sense, because when I was in undergrad school, it's almost 10 years, more than 10 years ago, I read a lot of papers from Japanese robotic scientists, and it was already there, all the concepts and things was there, but it's just not popular in other fields. It's just a very narrow branch of, robotics community. Like, for example, there is a big conference called IROS, which is co-sponsored by the Japanese Robotic Society. There are a bunch of those things because Japanese robotic scientists and engineers are working on those things. So it was really young at the moment, and later, around 10 years ago, I think George Whiteside published one paper in Angewandte, I believe. Then it becomes pretty popularized, and other fields people, in general, material scientists and chemical engineers are recognizing things and become very popular. And now I think it's not young field anymore. So as engineering is when the field is not become young, it's kind of getting a young adult or start to get a job kind of period. The question is, engineering is really about solving problems, and it's a purpose of its existence. So where it can be used. So I think that's the critical moment that people start to answer the questions, because when the field is very young, it is totally fine, and it's actually not matter at all to just exploring interesting ideas, developing the conceptual things, playing different things, because it's all great because it is really growing still. But when it hits some critical mass and critical stage of the development, it have to start to answer the question, because it is engineering-driven technologies that very actually can be used. And I think it's still kind of debating stage yet, but I personally wish people can find the solutions or answers for that. But it's really not easy, in my opinion, because soft robotics is actually not a robotics in classical definition. It's something new, something very new. It's not a kind of a continuously developed form of a robot, but it's some kind of a very different thing that emerged outside of the classical robotics field, but it just happens to be actuating and dynamically interacting synthetic system, which we only have a word to call it as a robot. So it's called as a robot just because we only have the word for robot to describe such a thing. But it's really not a continuously emerged form of a discipline from classical robotics. So it's a challenge, because the soft robot, because it's not continuously developed from the classical robot, it's not really suitable to do the same job as the classical robot do. And so I think it is quite a challenge. And many people try to answer that. And some of the folks that I personally collaborate also try to answer that. And I personally see some most excitement in hybridization the concept, like instead of try to find out of the use of the soft robots as an independent entity or independent system, which looks, I think, is a little more futuristic. It's very challenging thing to think about it, because unless the soft robotic system eventually becomes something similar functionality or capability as the animal body, it's going to be very difficult to be independently useful. But I personally like the idea of a hybridization concept, that is some part of the conventional robots are being replaced or adjunctly added by those interesting systems, so that kind of compensating some of the limitations or problems of a traditional robots have suffering is being kind of amended by this kind of soft robotic concept. So I'm more of a hybridization pathway guy for now. But many people like the idea of orb soft-bodied robot, which is very futuristic. But I think it will take more time to be actually being fruitfully emerge in something useful form.
Great. Maybe I want to go, before going to SanaHeal and starting the company, I think that's also a very interesting part. But in the PhD process here, you try to, I think, to push as much as you can to come up with innovative solution or new ideas. And I found what you do is really interesting. If you can tell us about the problem that you try to think, because you're most time critical and you try to push as much as you can. And you did an amazing job in the research. And if you can tell us about the problem, what you try to solve in your research before going to SanaHeal and how it started.
Yeah, well, so in first half of my PhD, I didn't really do my research to solve a particular problem. Maybe because I was younger, so I was more energetic and more kind of imagination and for fun driven. So at that time, I just do whatever I think it is fun. Like my first half of the PhD is just spread all over around. Like I did so many weird and different things. I did gel-based software actuators, like magnetic thing, 3D printing, sticking gel, whatever. It's just all over the place. It's just just for fun. But later I realized that, I cannot do this forever. So I have to find my purpose, that what's the problem that I can solve. I think it is twofold. First of all, personally, I'm always interested in biomedical thing, because I still can see in my SOP that in my grad application, I wrote that I want to work on rehabilitation robotics. And why I wrote that is I spent almost 2 years in hospital with my brother, because my brother got injured a lot. And I see the need of various medical technologies, but at that time was I was really on robotics, so I was kind of on rehabilitation robotics. But in general, if somebody is staying 2 years in hospitals, from ER room to ICU to every single stage of the hospital, there are a lot of problems, and you pay a lot, but it's really, many of them are suboptimal solutions that pay a lot. So, medical is personal problem that I always wanted to solve. And second, there's more realistic constraints. Happens to be I worked on hydrogels among many soft materials. And come on, where it can be used in elsewhere. It's a gel, it's a hydrogel, it's a water-based gel. It dries out in one day if you take in the air. It is not useful outside of the wet environment. But can we use this underwater? That's also a little realistic, right? So other than underwater, where is always wet is biological system. So it happens to be the hydrogel system is most useful by materialistic characteristics in biomedical. So it combined this realistic and personal reason. I wanted to make some biomedical stuffs if I want to make actual impact. And what I can do, I cannot say I want to cure cancer. Well, I want to do, but I just can't contribute. So, but happens to be I worked on adhesions and solid hybridization, those kind of thing. When interestingly, adhesion is one of the really, really, really few mechanical phenomena that is relevant to the biomedical engineering, because basically repair process of every broken thing is about sticking things together. So why not? So that's a kind of thought process, and it took I think 3-4 years to transit from complete material and mechanics works to something I can call myself as a biomedical person. It took 3 years because it just needed a lot of experiences about preclinical models whatsoever. But I was lucky that I could finish. But I don't recommend to do this for other people because it's too risky.
Yeah, I feel to be honest, I really admire what you did, and I think maybe the decision to start SanaHeal, I think that sounds very interesting. Maybe I read what you wrote. Why did you choose to do that? And I really like it what you said, and I feel a lot of courage to do that. I mean, you have a really strong record of research. I mean, very intelligently and be reviewed. I think it's and risky, which is not so common in my opinion. That's what I think. But can you tell about that article, the small one you wrote, and your decision to let's start and go for the other side and not continue? Can you elaborate why you did that, and do you think it was kind of risky decision for you because you did something here? I mean, solid research.
You mean the transition?
Yeah.
Transition between academic and non-academic
Exactly.
career?
That's the first. Yeah, that's the first part, because I think it's just. I feel it's so you're courageous here to mention your opinion and why you did this to go for the.
Yeah, well, that's a question that I personally get a lot from my friends and colleagues, because I didn't intend it, but somehow my career development looks so much to become one of your faculty. So I got the same question a lot and a lot. Well, I personally don't think it is involved any courage to do it, because, well, come on, like, I am a scientist and you are a scientist probably too. So we have to gather the evidences to make the decision about certain phenomena to what gonna be the prediction. So it's the process of gathering various information to help me to make the decision, and which actually doesn't involve much of courage, although it's risky. The thing that I decided to do a non-academic career, other than academic career, which was actually pretty easy for me to go academic career, is two things. First of all, it was a realization that if somebody really wants to make a technology being actually used in people, it requires not only development of technology, which is generally start with the paper not end, but start with the paper publication. But the problem is some areas, especially like biomedical engineering whatsoever, the risk involved in commercializing a technology from the very basic, like a lab-grown technology, is too high. So I tried to find the various other options, but I just simply found that it gonna not happen if the inventor is taking that responsibility of getting risk to push things into the market. So it was a very stark observation that I got, is it's really just the two of one. I don't continue to push it into the market, so it will never be gonna be commercialized, or I push it to the commercialization so that it have a chance to become a product to be actually used. So this is really the first thing. The risk involved in a commercialization or product development is way too high. There are gonna be no big company that magically license your technology and do all those complicated. No, there's nobody. So it's really a matter of whether the inventor really can push it themselves or just to let the technology languish and die off, just slowly forgotten away, is not really get to the war. That's the first thing. The second thing is I have my personal opinion about doing working in a university setup. Is I think a university job, faculty job, is really bad in financial outcome. I think everybody would agree it's horrible. It's really bad. But that job is very unique in a way that is education. It's all about education. It's entire like 100% about education, educating the younger generation to help them to intellectually and career-wise be developed. And there, I see some unnegotiable problem I faced. Why? Because I identify myself as engineer. And if I keep teaching younger people, those youngsters will also likely be wannabe engineers. Because I'm an engineer, I want to teach next generation engineers. But here is the problem that I faced. Engineer is the people who need to be able to solve the problem by using science. And that problem should be a real problem to actually benefit society. And therefore, by seeing the statistics, more than 2/3 of the engineering PhD eventually work in industry. Just a matter of fact. How hard they want to be a faculty or research doesn't matter. It's just at the end of the day, statistics tells us that more than 2/3 of the engineering PhD works in industry to work on companies, startups, or whatever related industries. So here's the problem that I asked myself, and I find this very astounded. Well, if I have to care about a teaching, which means I'm gonna get a job in university, I will work as an engineer, so therefore I will teach engineering to grow the next generation engineering. But come on, engineer is about solving real problem, and more than 2/3 of those students will work in industry. But if I don't have any experience about the after the R&D, if I have a zero experience or understanding about what's happening after initial R&D, but there are tons of things, right? If I don't know any of it, can I be able to be a capable teacher? Anyway, it just to me it doesn't make sense at all. So even for me that I want to become a faculty in some time and I want to teach the youngsters in university setup, even that, I thought that I have to learn, I have to first learn the full circle of a process that engineers should do and actually do in the real world. But how dare I can say that I can teach us the brightest mind in the world in some other place if I never ever see or finished my own full circle, but how dare I can teach them to do that? So it was just a complete mismatch. So combine these two. First, well, I don't want to see my technology that I hardly invented myself is dying off on the shelf. Nobody use it. I just don't want to see that. Second, even though at some point in my career, if I want to teach people as an educator or whatever university or whatever institutional setup, still I think it is essentially important to know that remaining half of the life cycle as engineer so that finishing the circle myself. And only when I can really wholeheartedly can teach the youngsters that how they can train themselves, how they can work and function themselves as a true engineers in the society instead of really just publishing something to get a fancy spotlight which die off in a few months. It's not the engineer's goal. Good papers are good. Papers are lovely. People like the papers. But at the end of the day, engineers should solve the problem. And it's really important to know the whole process because otherwise, there are always danger to misguide the bright-minded young people, and I think misguiding smart and intelligent youngsters with high potential is not only wrong, it is a crime to humanity. People should be very, very careful about not misleading them. But the lack of knowledge is always a great setup to misleading somebody. So that was kind of ground basis of my decision to, seemingly for both ends, I may want to go a little bit of non-academic career first.
That was powerful, and I totally agree with you 100%. It should be that way, and I think I'm glad that you mentioned that because I think it's maybe the system set up in a certain way, but I think having this experience, you are right, to change the way we teach younger generation in university. Totally agree with you. Totally agree.
Well, like if I just a little bit adding on that, it's like because I'm from mechanical engineering, and you should be very familiar with the mechanical engineering because robotics people are mostly mechanical engineers. Say 30, 40 years ago, in the golden age of the mechanical engineering, I should say, it was like that. You know, the most founding peoples about most of the mechanical engineering disciplines that like base people who laid the ground were from industry. You know, they trained in university, they go to the industry, they did a great job, and when they kind of get a little old or cannot just work that hard, return back to the academia, they teach people. So basically the workforce switching between industry and academia was really, really flexible at that time. And I think that was an ideal kind of engineering school. It's basically when the engineering school first established in United States. It was not there. It was all science before. When the engineering school first emerged, it was that mode. And somehow we currently lost its original form. It has been segregated. But I think it's really now the time to everybody think about we have to go back to the original form because it was originally like that.
Awesome. So I want to ask you again here when you mentioned having new idea and you mentioned papers great and that's okay, the current in academia, but now you're switching for real world application here and real problem. How you make sure what you did is meeting the end goal here to be commercialized or to start? You see, is there a difference here in thought or design to change things here?
No, I think that's another thing that I really learned by the process. It's really important to talk or learn from people who actually know the problem. For example, in biomedical related, well, it's doctors, it's surgeons and clinicians. It's important, in my opinion, that it's when it's another problem of the segregation between the real world or industry and academia is that it's very important, I think, even in science, not only the engineering, is not to assume without evidence. So we should not assume the unmet need. We should not assume the nature of the problem, and we should not assume the solution that would be necessary or be preferred or be adoptable. So not to assume, it is just important to engage and talk with the people who actually know or experience the problem and work with them in collaboration. And that collaboration needs a lot of personal efforts or sharing many things. But I think it is decent price to pay because it is very difficult for academics who just develop their whole career within very small boundary of university in small labs or community that how we would know that all those real problems that people actually suffer outside. At least we have to try to do interview, right? Or ideally, we have to work with the people who actually suffer from problem, know the problem, and can tell you whether this particular solution, like what kind of things that solution have to achieve. And if we have something that looks like a solution but in very crappy form, does it have a potential to be actually become a solution or potentially being adopted in a positive way in those things? So we have to learn. It's not a matter of assumption. That's not even a matter of intelligence. There are many smart people in academia, but that smartness cannot overcome or the lack of experience. We just need to ask and work together with the people who understand the problem. And that's somewhere that I personally try to do and enjoy so much. You know, it's like it's so fun to listen from somebody who does completely different thing. But at the same time, it is my major source of frustration sometimes when I watch all those works are published nowadays that it is kind of conspicuous that this process is lacking in many times. Like people just imagine the problem, imagine the solution, and imagine the evaluation even. So it's going nowhere because it didn't really reflecting the true unmet demand that's spoken by the actual user, or I should say. So that's a thing.
That's a great. Maybe I want to ask you quickly here, what the thing changed in your perspective? You have this experience, but that thing that you think was very interesting to have this perspective. You mentioned great stuff here, but is there something key, the way of the viewing problem here? You listen to people, but in the design, is there something with changing your perspective in this experience now? You are on the other side. What that thing changed your perspective so far?
Well, I think it is well, one thing that I developed myself continuously by doing this in perspective wise is I always try to decipher complaints to the engineering questions. So it's like when the one reason people don't like to listen the actual complaints from actual user is they are not written or they are not expressed in the language of science and engineering. It's just like a plain complaint. I don't like this. It doesn't work, something like that. So one perspective that I have is it is very important capability or training to do like listen those complaints and converting that into a actual question, scientifically define the question or engineering question that we can possibly think about how to solve it. So that's a kind of interesting perspective I developed. Like for example, if I talk with a clinician, they just can talk one full hour about something doesn't work. But in plain language, it's just a list of complaints that doesn't have any sense of what's actually the issue. But carefully listen that, and we have to convert that into a kind of technical language that we can define the functionality that lacks. We can define the performance that doesn't reach a certain level, something like that. That's a something interesting perspective that I developed, and I think that's a something that universally useful and fun process probably for all the problem beyond the biomedical things.
That's a very good point. Maybe quickly, why did you choose the name SanaHeal? Is there a reason behind choosing the name?
Yeah, well, I almost forgot because it was quite a time we brainstormed it, but we work on a kind of sticky materials like a tissue adhesive thing, but at the end of the day, in eventual vision wise, we wanted to promote the healthy healing of the people because we are working on various repair technologies, healing promotion technologies. So in vision wise, it's really a healthy healing is something that we wanted to achieve. But you cannot name the company as a healthy healing. It sounds like it's so dumb, right? So when it sounds dumb, but we still want to have that meaning, the trick is you look in the Latin words. And the heal is good. So, but we found the healthy in Latin was sana, so we just combined that. So it's a very common. I think people do this like endless time. Like people first choose something they want to tell, but in full English it just sounds so dumb. So they find some foreign language. But if that foreign language is actually a live language that people use it's also look dumb for that people, right? So we have to choose a language nobody use. The best is a Latin, classical Latin. No living human use that as their actual language. So it sounds like a fancy, nobody actually uses, so nobody really knows the word readily. Yeah. So it's just kind of I think it is a common company name trick.
That's a good, yeah. Maybe, I think 3 questions left, but I would like to secure the technological roadblocks. Now you have see the other side of the actual development here. What's still challenging? You mentioned at the beginning, at the first year for PhD, you work at 3D printing, different stuff, material, etc. What is still challenging so far? You have this real experience and you figure out that's really challenged so far.
Well, so far, the biggest challenge I am actively suffering now is how to scale up. How to scale up in reasonable way, reasonable include financial terms, and reasonable means also the regulatory compliance too for medical product. This is a big question that I never asked myself when I worked in a university setup. I think nobody would ask this. But it turns out that it is really something that can be a life-death question. So if they say, like I have technology, it worked perfectly well in my hand-cooked small batches. But if there is no financially, technologically, and regulatorily compliantly reasonable way to scale this up to the cost that we would possibly be able to even imagine to sell in a reasonable price, it's done. There's no way to commercialize. But this knowledge is entirely belongs to industry. Here is the thing that I personally was so stressed out, but I also really excited because the scaling up knowledge is something that entirely belongs to industry. Because it's rarely being studied in the academic world, because academia is basically a small batch world. So I cannot do it myself, but I can share what I have done and work together, but it cannot be led by me because I have no idea. I'm not expert at all. So it's entirely industry. So we have to find a contract manufacturer or engineer who know those manufacturing processes and work with them to develop this scale up protocols and test run, which cost 1 to 2 million per each product, a lot of money. So it's a stressful part, but it's really fun because, well, probably that's why I do research. Anything I don't know is fun. So that's a challenge. And I think sometimes when people try to push something in a translational way to actually make it into product for physical platform, robotics is obviously the one because robotics is always have some form of the hardware belongs to it, right? How to scale up is question. And if it is not a scalable technology, is that high price is possible? It makes sense. That's the second question. So that's something that I'm actively trying to, I have to do with the other engineers, but it's hard. But, I can tell you, like, I more and more love industry PhDs. They are beautiful people. They are so professional on things they do. I really respect how knowledgeable they are. So I already kind of didn't have those illusion, but I really kind of now they strongly feel there is some very unjustified illusion that the PhDs left in academia is smarter than PhD go for industry. Oh, forget about it. That's an entirely ignorant statement. Industry PhDs are beautiful. They are really doing well on their job, and there are a bunch of critical knowledge that only being developed and retained and being innovated by industry PhDs, which is absent in academia. So mostly nowadays, like my collaborative effort was 100% academia, but nowadays I think 2/3 is industry fork and only 1/3 is academic force, including clinical scientists. I actually like industry forks more because our communication is more straightforward and they are well paid. They are like 9 to 5. Well, so I don't need to have a meeting with them in the middle of the night on Sunday. Great.
That's true. That's true. Maybe 9 to 5 when you start in SanaHeal. Do you think it's stressful a little bit at the beginning?
Now, for me, it is impossible. Like I don't work like that. I work a lot more than that. But
yeah,
at least my counterpart in the contracting industry counterpart is 9 to 5 work. That's a great thing, It's sometimes very emotionally tolling to work with the postdocs in academic setup that everybody work whole day and weekend.
No.
Well, it's fine for me because I live alone. I don't have family here, and I'm workaholic myself. It's fine for me, but it's sometimes emotionally tolling to see my colleagues are working so much and paid so badly, and I can see they're tired and they're frustrated. It's sometimes not a good feeling to see your colleagues are all like that, but for me, it is really happy to see that my counterparts are balanced life, well paid, they're happy, and so therefore they can focus on what they do on the time that we work together. So it's a kind of refreshing feeling. But anyway, industry is a great thing.
You encourage me, but I totally agree with what you said, and that's true. I agree with you. Maybe a few questions for you, Lift. What's the features do you think, how do you see the future of the company here? I know it's in the beginning, but when you try to think about this vision, is it important to you or just enjoying the process by itself now? You have the problem of scaling up, but generally speaking, the vision here.
Well, I think where there are lessons I saw from many startups rise and fall from university. So one thing is, I think it is important to have a big vision, and our team's vision is make something useful to help people to repair their injuries and heal better. For few first indications initially, but we wish it could to be grow over time in various different places. So eventually we can provide any solution people want to do, but that's a vision. But as a more practically speaking, as a company, or when any startup company that would be, I think it is important to make sure that the first one or two project actually work out to the market, get clearance from regulatory bodies, get to the market. It could be used in a pay. I think that's very critical because that's something that I try to keep myself because academic people, including myself, I'm 100% academic by training, have a bad habit of too futuristic.
Okay.
I get it. Have a bad habit of only talking about unrealized future and like a big picture, like a far away goal. Well, that's great when somebody work in academia, but if they keep doing in industry, I think it is the fastest way to bankrupt. So I work with a very experienced CEO, serial entrepreneur. So he's the guy who keep things controlled. But myself, who are working on a technology side, I'm trying to keep myself that, well, I have a lots of problems that I want to tap. Maybe a lot of R&D will happen in the company still, but we really need some focus to get the initial most mature technology to be processing its product development and processes so it really can be actually commercialized and get to the people first. And then we can enjoy this cycle by repeating it again and again and again and again so that we can actually delivering our promises into something out there. So I'm trying to keep myself because you have talked with the many soft robotics for every week.
No, I apologize
so
because I think this question, I apologize for the question because it seems because I'm still in academia and, I understand it's not the right question now to go very ambitiously here in the future. But that's good.
No, it's a really good to about have a visionary, but it's a something that because I can tell because I came from academia, I'm still in academia, so I can tell for everybody in academia it needs some degree of self-containment because if it is not made, everybody in academia, including myself, we can spend the whole day by talking about future, but we don't deliver.
Indeed. Maybe I could ask you, if you look to the field, beyond what you do, what is the next thing you think very, very important to the fields of robotics? You now have the two eyes here from academia and industry and starting your thing. But if you just tell guys, I think from my experience, that's something you should also consider a research. If you're in academia, push here more effort in this direction. What that direction do you think? Yeah.
Well, I think it is for like this kind of unconventional robotics, I should say, in the
Yeah.
field. I think it is now the moment is mature to start to think about some translational targets, you know, because there have been a lot of a concept out there. So, what can be a fastest way to kind of convert these basic technologies into something useful and potentially being used by people as a customer? One thing that I think will be the is happening now um, is it's not actually robotics, but more like a robotic interfaces, in my opinion. That the companies like a Facebook, now Meta, these peoples are investing a lot on artificial, the augmented reality or this virtual reality, and they have their own internal corporate labs that are trying to make a new generations of interfaces that help them to interact with the virtual reality or even some hardwares like a robotic system away from somebody remotely to get better interfaced, which potentially be a little more complicated. So where that is a little unconventional robotic system or sensor system may be very helpful. And I think those are kind of a low-hanging fruits that people can go for actual translation. So in my opinion, that there are enough of basic technologies are out there, at least conceptually. So maybe it will give a really a healthy culture in the field that people start to find not huge, but just several very realistic and obviously impactful ways to use the technology in very intimate way with the people, and start from there. There gonna be more and more momentum will be grown how people can make this into more and more useful out there. So I think that will make the overall field much more like energetic, vibrant, instead of fully focusing on a futuristic concept fight. Like, I even don't know whether there is any remaining insect or animal left to be inspired. So I like that. I started my whole research career about by inspiration. I wrote several paper about that, my own inspiration in interesting creatures. But that's good. But I think everybody have to keep doing it whenever they have a good idea. But at the same time, I think it's really gonna make the field very healthy to identify few problems that actually this developed technology are being used or translated, and kind of doing a parallel job. Like in one side, people are asking questions that nobody know where to use. I think that's most of the time wasted, but still have a very small chance of breakthroughs. I think it is a great thing to do for every research field. But at the same time, as an engineering, try to use some of this generated knowledges in a tangible form. So I think this kind of a parallel track will be more interesting. I think it is going there. People are doing that. Just currently is still a little completely not in that way in compared to other fields where industry is really well developed, so people can actually connect it with the companies to ask and get the feedback. That's a little more challenging for soft robotic community because traditional robotic companies are generally not very hugely interested in this thing. But it doesn't necessarily be a robotics company, in my opinion. It can be a healthcare company, it can be a medical device company, it can be a IT companies like a Facebook or Apple, that wherever that they find the technology be useful, they can give a feedback, and the big companies' feedback generally in the form of the money, which is sponsor the research, which is a great thing to promote the whole thing as well. So that will be, I think, is ongoing, and people have to try more on that. And once this kind of a parallelism with the pure academic exploration and a little industry relationship driven tangible conversion into the real application would make the whole field so much healthier than everybody is watching National Geographic to find the next animal to be inspired.
Since you mentioned, why do you love rabbits? I saw that you're a rabbit lover, if I understood. I'm
Oh,
curious.
I don't know. I don't know. But I think true love is not explainable. So I cannot explain, but it's so cute, you know. I even almost feels like there is a theoretically quantifiable quantity called cuteness, and the rabbit is overloaded with it. It's so cute. So I just like it. I had multiple rabbits myself when I was in Korea. My first hugging door for sleep was rabbit, so I think I was somehow emotionally attached to the animal. And you know, there is a lot of rabbits in Cambridge, in Boston. There are so many. Like, I even had a theory that why the United States is so powerful. It's because 50% of the rabbit population lives in North America.
Awesome. So I don't know if you have any advice or something you'd love to share, maybe in this journey, stick to your mind, maybe advice you give it to you would love to give. And what also makes you fulfilled? Because I feel that your way of thinking, I really admire. Again, I feel that you are different in a sense that more critical, and you try to not to go with the trend. And I think that's also good quality to have your own mind about the things and analyzing them. You see what I mean? So, what makes you fulfilled in that sense, and how you develop that? Yeah, they're critical. Be
Well,
critical. Yeah.
I think because I'm from Korea, which is Asian culture, very competitive. My compatriots are very similarly tough folks in that sense. So I grown up in and educated in my early part of my part there. So I kind of feel always, and I actually feel the same in the U.S. too, is that we have to forget about others are recognizing, evaluating ourselves. We have to don't care about it. It's just all about ourselves. Like, for example, when I write a paper, well, I like to publish in a fancy journal. I like the figures are being great. Why? It's not because those fancy journals are a good thing. It's not because fancy figures are increasing chance of getting those journals. It's not. For me, it is my self satisfaction. If I push there, many more people will read my work. Why not? And research paper is a form of art. I just wanted things to look beautiful. Why not? So it's same thing. I think we need to sometimes a little forget about how others evaluate others, but it's more like a better to focus on ourselves. Like, just do what we want to do, and just critically think about why I have to do this, why I want to do this, what is my purpose. It's almost like a religious question. What is my purpose? You know, what is my why I do this? Like, there are so many great things to do, but why I now need to do this? These are more existential questions, almost religious philosophical questions, but I think those are very important because I sometimes, like, I have worked and did well in competitive academia, frankly speaking, but I really hate that because I don't say it is bad by itself, but just environmentally, it pushes young, bright-minded folks too hard on certain criteria that they define as a success, which is actually not giving success at all. Is that people generally, sometimes in such an environment, people forget to ask very simple questions. Very simple questions. What I want to do? What's my purpose? What's the thing that I really like to do? But rather, people in such an environment, people sometimes being forced to choose something that looks good by this community's definition. That's really bad. So to me, for my research career, I frankly don't care about a position title whatsoever. It can be anything. But I always try to go to better place. I always try to get more money. That's an obvious thing that every human being have to pursue. But the most critical thing that may drive all the decision is my purpose. What is my purpose? And for me, my purpose is as an engineer is I have to bring something good, something truly make the difference in the area that I care. So that's my purpose, and there can be many ways to pursue it. So I just need to always optimize and seeing different opportunities whatsoever. So I think people have to just ask a simple question. I talk with many starting grad students. Many people ask questions, concerned. Sometimes it's very frustrating that people don't have a room in their mind to ask very simple questions. It's like they're asking like, what fields are publishing more paper? Like, is this topic have a chance to publish in this journal? Well, I can answer that because I have knowledge about it. But the fact that I can answer that means that's the right question. So in that sense, I also kind of, because I kind of switched a little bit to the non-academic career, I also start to I didn't think about this at all before. Like, because I'm fully in academia, I could stay in academia forever. So that's why I didn't think carefully about it. But now I really feel that sometimes people evaluate somebody's career paths in certain criteria, and being judgmental that what career path is successful career, what career path is not successful career, what career path is more superior than others and inferior than others. I think it is a overall very toxic attitude that academia have developed. Somehow we have to discard all of them, because those are predominantly pre-existing criteria are really like messing, especially junior researchers' mind in terms of helping them to asking the question, what's really the purpose they feel to fulfill. And people get scared if the purpose, that something that they really like, is not matching with the community's criteria about a success or superiorly good career. People get scared. People got very insecure feels. And there are courageous or not courageous. There are kind of less sensitive people who just don't care about it. They just do what they're, which is beautiful minds. But smart people also tends to be more sensitive on those things, because they're smart enough to actively processing all those reputational inputs very well. So they got scared, and sometimes they make a decision based on this kind of community pressures, peer pressures, and sometimes PIs not helping but exacerbating these things.
Yeah.
So I think we really need to collectively have try to discard this thing. There is no superior, inferior careers. And one thing that I truly love and really enjoy, since I choose to switch a little gear, that when I was in academia, most successful people have very monotonous career. Did a PhD in grade school, did a postdoc in a grade school, get a faculty job in a prestigious university, got a several early career award, got a tenure, got a several mid-career award, got a several senior award, lectureship, and the big guys in the community. But that's very monotonous. But one thing that I really impressed and loved when I switched gear a little bit in a non-academic career is most successful people in there have extremely, even like unimaginably complicated careers. They did that. Like, it's somebody was a professor in some university, quit and go to the company and sell the company and do the completely different thing and go back to university and go back out to the company. It's just almost so random for everybody. So it's so unique for everybody. So I think that was really inspiring for me. And for me, it's also kind of feel a little risky of not getting into cozy academic career. But whenever I have a chance to meet those non-linear career folks who are amazingly successful in what they do, it's giving a kind of a comfort of mind. Like, gee, like this guy's CV is a mess. but it's still great. What's the point of worrying about those? So I think it would be really great if the academic institutions or whatever, everybody, try to find out. There are a lot of people who have such a non-linear careers. Maybe it would be greatly helpful to introduce those peoples or to the community that look, this guy's CV is just random. It's almost like you have a multiple name card spilled on the floor and just picked up. But it's still so much successful. So the non-linearity of the career doesn't mean not successful career. It's actually leading to the more success. So I think those kind of thing is that my advice, which not even advice, because I actually learn it now actively. So it's something that I would love to learn 10 years ago, I should say, that the careers can be very non-linear and there is nothing to worry about it. And so there looks so much fun and excitement to follow the heart of what they want to do. And there are so many unpredictable ways things are being developed. So that's something that I would want to say, don't try to limit one's focus, especially in academic programs in all the junior researchers. Don't try to think or idolize a very common, linear, monotonous careers in schools. Don't take it as the epitome of a successful career. There are a lot more. There are a lot more exciting or multiple variety of colors of successful careers. And it sometimes requires a multiple switching between fields. So those are out there. Just fact that they are not a faculty who are interacting mostly with the students, so it's not easier to get exposed for junior researchers in school system. But that doesn't mean that that's not a good thing. So I think just take a look at the many others outside of the school and get inspired by those people's non-linear, yet extremely successful career. But that doesn't mean that everybody should drop out of the Stanford to become next to Mark Zuckerberg, or everybody have to drop out of the Harvard to next to Bill Gates. It doesn't mean that, but just the fact that there are many non-linear careers out there. Many of them have a PhDs. So it doesn't necessarily need to idolize and try to make the one's life plan based on very monotonous academic career that probably many of the successful academics in school system have. So there are a variety of different ways. And therefore, we always need a role model to fight our own fears, right? Because unpredictability is the source of the fear. But if somebody know someone who have a so messy career but yet very successful, I think that's much helpful than people who have a beautiful, almost exemplar career that every single step is success and elite. I think it's much better to take a look at the role models that have a super messy CV.
I have to say it. To be honest with you, I'm really inspired by what you said, and I consider this is really, I'm honest, the role model for me to say these words. We need that words, and I think that's really powerful from you to say this, and I needed, to be honest, to listen to that. So thank you for saying that. Thank you.
Yeah, well, I have to say it because I'm starting to make my CV messy. So far, it was clean. My CV was impeccable, but now I start to make it very messy.
But I'm sure you're doing. I'm sure you would do a great stuff. I believe in that. So I don't know if you have any final words like to say for people listening. Any final words like to say?
No, and it's just great honor to have a chance to talk with you. I really love, and you are doing a very interesting influence on soft robotics community, I can see. So hopefully it will continue to do a great job. And maybe it will be very interesting if you start to increase your outreach to more conventional robotics works as well over time.
Yeah.
Because I'm not a roboticist, so I cannot say for them, but just I feel like people like you can be a very powerful ambassador who try to collect the different voices in the same community, but generally not work together. That will be very interesting because there are some opinions that traditional robotics folks are having about the community, and there should be a lot of value that people have to learn from it.